Welcome, everyone. We are happy to present Sidus Space. It trades on the NASDAQ under the symbol SIDU, and it's a satellite operator. This company focuses on commercial satellite design, manufacture, launch, and data collection with a vision to demonstrate space operations for new technologies and deliver data and predictive analytics. Sidus Space serves customers worldwide, and we are happy to welcome the founder and CEO, Carol Craig. Welcome, Carol. How are you doing today?
Thank you so much. I'm doing very well.
Good. We're happy to hear your presentation. Take it away.
Great. Thank you so much. So as mentioned, my name is Carol Craig, and I'm the founder and CEO of Sidus Space. Sidus Space is a space as a service, as in outer space firm, providing multiple solutions and services across the space domain, including mission-critical hardware manufacturing for both space and defense, engineering, in-house satellite design, manufacture, and in-orbit support, and space-based data collection. So we have a model that's similar to larger companies like Maxar and some of those, but with multiple lines of business that are complementary to each other. Our Earth observation and manufacturing vertical offers our customers separate space and defense services or an end-to-end solution. Our mission is bringing space down to Earth. We're focused on enabling our existing and future customers to access the space ecosystem at low cost, so lower than the current market, but with a primary focus on providing access to space-based data. And what makes this possible is our LizzieSat satellite and our planned fleet of small satellites that will provide Earth observation and remote sensing solutions to our customers. And we call it our multi-mission satellite for a multi-mission constellation. At the end of the day, data is really what many of our customers are looking for to help them meet their mission goals. So we offer that end-to-end satellite design and development while also moving toward a higher margin satellite services with an on-orbit data services line of business. And although there are a few smaller companies providing data, they're limited because of the size of their satellites and their singular focus on one type of sensor or technology data. We're providing higher value data using a suite of sensors on a single satellite. So for example, when you think about the type of data or the amount of data that can be transmitted, each of our satellites can transmit at a minimum 100,000 megabytes of data per day. And this is multispectral, hyperspectral imagery, GPS, or automatic identification system type of information, and then other data related to the technologies aboard the satellite. So as a data point, 100,000 megabytes of data is approximately 100,000 images, depending on that type of sensor. And the industry average for the selling price of those types of images is anywhere between $10 and $24. And the raw cost of that data can be as low as pennies per megabyte. So there's definitely a high margin opportunity there. But the real value of our space infrastructure or satellite fleet is that it can grow with the industry and the advancing technology. And again, each satellite can service multiple industries with different types of data, including aggregation or fusion of that data from the various sensors or technology. So while Sidus is new to the public markets, we aren't new to space and aerospace. Sidus has over a decade of experience manufacturing space and defense hardware. And as CEO, I have nearly 30 years of experience in aerospace, aviation, traditional space, and commercial space. And specifically, I have over 20 years of entrepreneurial experience running space and defense focused companies. In 2012, Sidus Space actually began operations as a spinoff from one of my previous companies. And my 30 years of experience and knowledge base with those companies is now integrated into Sidus Space. So a little bit more about our leadership team. Our leadership team is built around the mantra of innovation on the shoulders of space heritage. Each member of our senior executive team has over 30 years of experience in their respective fields, and they bring a really good combination of traditional and new space expertise and leadership. Our Chief Technology Officer, Jamie Adams, has 35 years of management experience and has worked for NASA, Boeing, and Lockheed Martin. Our Chief Financial Officer, Teresa Birchfield, has over 30 years of finance and accounting experience, with more than 12 of those as a public company and CFO. And our Chief Mission Operations Officer, John Curry, is a former NASA flight director and program manager with experience in commercial space programs as well, including Blue Origin. So the market data. A lot of us have seen the numbers and understand kind of, what is coming. But I guess that key message here really is it's not if, but when. So we're at an inflection point with space, with the expectation to see rapid acceleration over the next few years. The number of satellites being launched each year continues to grow, with the next decade projected at around 18,000. And a good portion of that is related to telecom, whereas our area that we're focused on is remote sensing and Earth observation. And so this inflection point also applies to space-based data that can be used to power analytics that can benefit nearly every industry on Earth. So our pick and shovel approach is to provide access to space-based data through our satellite constellation, our space infrastructure, so that everyone can have access to that data and can make informed decisions and impact their businesses or their day-to-day life. A little bit more about the market. The satellite market currently makes up the largest value in space, over 70%, with a forecasted compounded annual growth rate of approximately 5%. This is according to several different research and marketing intelligence firms. And the reason for this positive trend in this lower Earth orbit data is a couple different reasons. One is an increased demand for uses beyond just images. New sensors and technologies focused on asset tracking, spectral imaging, infrared detection have opened up new opportunities for even more industries and markets to benefit from space-based data. Also, there's an improved ability to handle and store larger and larger amounts of data, and then reduce time between data collection and distribution. We actually have a partnership with an edge computing company, and we're integrating their software into our satellite. So we'll be able to process that space-based data on orbit prior to actually transmitting to ground. So that saves time, and that also saves money. So the opportunity we see is the ability to drive a market correction. The satellite market has been largely dominated by a few companies, which means higher costs to customers. But we understand the cost of space-based data, and we believe that lower, more realistic pricing to the consumer will result in actually a much larger market capture. So one of the questions we get asked quite often is, who are our customers? And sometimes I'll say anyone and everyone. And really, in some respects, this is true. As you can see, the potential and our current customers include a number of areas of the U.S. government, international governments, academia. The space ecosystem supply chain is a large one. Startups, Fortune 500 corporations, and then even consumers. And as I mentioned previously, we provide manufacturing, engineering, satellite operations, space-based data to our current customers. And each type of customer shown on this slide has multiple areas of need that can be potential revenue for each of our offerings as a space as a service company. There are a multitude of cases where data from space is useful, aside from military applications, and they include weather, aviation, maritime, insurance, financial services, and navigation. But a good example of an industry that can benefit globally from our satellite data is agriculture. So satellites with our type of technology can monitor livestock or measure crop yields, including helping farmers decide whether to irrigate, fertilize, or harvest their crops. And this also rolls over into the commodities markets. And satellites can also provide farm asset and management and tracking. So the same type of benefit also applies to energy companies, so identifying spills or environmental damage, as well as monitoring general structural integrity of objects. So, and furthermore, it simplifies the inspections in remote or harsh terrain areas. And then last, I would say that Earth observation satellites actually support globally the monitoring of many different climate variables, such as deforestation, greenhouse gas concentrations, pollution levels, and rising sea levels. So to talk a little bit more about our advantage and who we are, what we've been doing, we've been actually generating revenue over the last decade by providing engineering and manufacturing for both the commercial and traditional space industries. And in particular, we've manufactured hardware for nearly every commercial and U.S. government space program that exists. And we're one of the very few companies that has hardware on the International Space Station, and the only commercial company able to launch 100-kilogram sized satellites from the International Space Station at this time. Our manufacturing facility is located in Cape Canaveral, Florida, and has been for the last decade. We're currently in operation with a full suite of machinery and equipment, including everything needed for assembly, integration, and testing of satellites. And we currently have IP related to not only our products, but also space-unique applications, such as developing vertical takeoff and landing pad interlocking pavers using regolith, or what is actually space dirt. And so although launching a satellite is becoming cheaper, creating space technology and operations is still difficult, and it really does require significant expertise. And this is just a small sample of the support that we have provided and are currently providing to space programs over the last decade. As you can see, our customers include OneWeb, Airbus, Department of Defense, Department of State, NASA, Collins Aerospace, and a number of others. And as mentioned, our experience over the last decade has included almost all major space programs, but most notably, we supported the Artemis 1 program, which launched in November of last year and returned a couple months ago. And we provided engineering and manufacturing hardware for the solid rocket boosters, core stage of Artemis, and also provided ground support for the rocket's systems and facilities, the mobile launcher, and the Orion capsule. This slide just provides a visual of the process for launching satellites, just to better understand what is involved and ultimately how to access the benefits of space-based data to execute a customer mission or deliver on needs. Everything from the production through the integration to the regulation on to mission operations center and then to data is covered by Sidus Space. We can handle everything for our customers, and we can also provide the services as standalone support. So our mission operations center is available to other companies, whether they are launching a single satellite or multiple satellites, so that they don't have to actually build their own mission operations center. Instead, they can work with us to support their on-orbit services. So a little bit more about our satellite and what makes us unique. We say think outside the cube because we are not in the CubeSat or smaller satellite range, but we're also not in the larger $300 million, large size satellite range either. And while all of our offerings are critical to our business and an important part of our strategic plan, our in-house designed and developed satellites are key to the rapid growth of the company. And this ability to provide space infrastructure and subsequently data creates this rapidly scalable, high margin line of business. We're currently manufacturing our satellites in-house, and we have several satellites contracted and scheduled for launch with SpaceX and NASA. Our satellite is a 100-kilogram satellite, as I mentioned when I talked about the platform and the ISS, which is approximately 220 pounds, about the size of a coffee table. That's different than many of our current competitors in the industry. And again, in the past, satellites were much larger, required longer time on orbit to see a return on investment or break even on the cost of manufacture. And then the pendulum swung and they shifted to a focus on these smaller CubeSats. But that also meant less functionality, less revenue per satellite, and a little more singular focus. And our satellite has several differentiators from the others in the industry, and one of those being the fact that our satellite is lightweight because it is a hybrid 3D printed satellite, which means that that's reduced cost and more available space in that satellite for functionality, for customer technologies, and then also for data generating technologies. We have 35 kilograms of space available for our customer or our own Sidus sensors. And as a data point, our own cameras only take up about 1.5 kilograms of space. So you can see that there is a large amount of space there available for multiple types of customers and multiple types of revenue. We also have an easy integration of our customer technologies and sensors during production because of its modular design and because we manufacture in-house. We use space-proven commercial off-the-shelf systems, which reduces risk, and it shortens planned production cycle to around 12 months or so, which is less than what the industry standard has been over the last couple of years. We also have the ability, as I mentioned, to integrate a suite of sensors because of the available payload space in there, or the technology space, vice just one. That means more data, but it also means more valuable and higher revenue generating data. We designed our satellites to be more reliable with redundant systems. They have a 5-year design life, which again means more revenue per satellite, longer on-orbit lifespan. But we also have the ability to deorbit if something like technological obsolescence dictates that we no longer need that satellite there. And we do that either by propulsion that's integrated into satellite or using reaction wheels, which actually allow us to manipulate the satellite. That also means that we have the ability for precision pointing, and so we can actually target different areas of interest as opposed to what some of the smaller satellites are able to do. So an important distinction, again, is that this is our satellite constellation, or the entire fleet of satellites. It's owned and managed by Sidus Space. So by owning and managing our satellites, we're providing a full suite of services, but we control the process. We're able to see those efficiencies. And we also, as I mentioned before, can provide those services to other satellite operators. So what we're building is our multi-mission satellite for a multi-mission constellation. And this allows us to capture customers from multiple markets with multiple needs. So not just a single focus on one market, such as maritime or US government. This slide describes our diverse revenue streams and capabilities in a little more detail. We really do believe that diversity is a key differentiator, whether it's diversity in our business model or diversity in the offerings of our satellites. And what's important to point out here is that both data and on-orbit testing revenue streams are tied to our satellite constellation. Our on-orbit testing refers to the integration of customer technologies, either to prove out space worthiness or provide them with regular data output from their own technology. And then this type of revenue is received in milestone payments during the production of the satellite that you're integrating the customer's requirements into. So revenue is received upon signing the contract with subsequent follow-on payments. So you're recognizing revenue during the production cycle of your satellites. Now, industry standard varies. It could be anywhere between 75,000 to 150,000 per kilogram, but that varies on depending on the complexity. And then once a customer has had their own technologies integrated, that customer can choose to receive data on a subscription basis throughout the life of the satellite. In addition to supporting customer requirements, I mentioned before that we integrate Sidus chosen technologies, hyperspectral camera, multispectral camera, automated identification systems for maritime tracking, and others. And that with those types of technologies integrated, our model really is a platform-based business model that works on the principles of partnership and scalability, much like software as a service. So as we manufacture and launch more satellites, whether we're supporting the customer directly or collecting and selling data using our own integrated sensors, the revenues grow exponentially, but there are smaller incremental increases in the costs. So this demonstrates a little bit more of the investment economics related to our constellation. Each satellite that's launched enables additional high margin data revenue streams. And what's important to point out is that the focus on data and recurring subscription revenue combined with the high margin, low cost data is expected to result in a faster path to profitability. And our low cost satellites benefit from longer life, that 5-year lifespan design, and then the decreasing launch and on orbit costs that we've been seeing in the past and will continue to see in the future. But lastly, I think most importantly, we're able to monetize the data in multiple ways. So selling direct to a customer or consumer through subscription models, or revenue sharing, or selling to aggregators results in a collect once, sell many model. And I know there's others that believe in this. One way to sell the data and reach more customers faster is through data intelligence marketplace platforms. And there's several already in operation that integrate both terrestrial and space data, but the space data is nowhere near the capacity that's desired by these companies to meet the needs of their own customers and industries. And at this time, there's very little advanced imaging, as I mentioned, like a hyperspectral and multispectral available on those platforms, providing the data that's needed to service industries such as mining, oil and gas, and agriculture at the levels that are really desired. The collect once, sell many mindset also extends to the orbit of the satellites around the Earth. So the path of a satellite covers many areas for many customers, and it results in servicing multiple industries. So again, the multi-mission satellite, as I mentioned, and our satellites are not just dedicated to a single industry or a customer. So in summary, Sidus Space provides a disrupting model based on the ability to integrate multiple sensors into a single satellite and support multiple customers with that satellite with both services and on-orbit data. And we combine this with our space heritage experience, our in-house manufacturing capabilities, and our multi-pronged approach to revenue to be positioned as what we believe is one of the top space as a service companies in our industry. Thank you so much. So Anna, if there's any questions.
Wonderful, Carol. Thank you for that presentation. What a thrilling time to be in your industry right now. So let's talk a little bit about your recent equity raise. You just closed on that. So tell us a little bit about your planned use of the proceeds.
Sure, absolutely. So raising capital is a necessary element, I guess, of rapid growth, and it also provides us the ability to take advantage of opportunities in the market and the space ecosystem, and especially in this rapidly changing and growing space domain. So the capital that we raised is being used to procure materials to finalize a meaningful cadence to launch our multiple satellites. And it's not only for our subsystems for building the satellites, but also locking in on launches, because it's really important to have the timelines for our customers of when our satellites are going to be launched. Our capital requirements directly correlated to the number of launches that we secure. So the more we can get into space, the faster we can grow our higher margin revenue production that puts us on an accelerated path to profitability. So we've got a lot of exciting projects in the works, and we're very optimistic about the balance of 2023.
Good, good. Can you give us an update on your launch schedule?
Sure. So our LizzieSat-1 launch is slated for later this year. Our exact date is dependent on a number of factors and different party schedules. We are very excited to have secured 2 launches with SpaceX for a total of 5 satellites over the next year or so. Prior to our capital raise, we did that, but we're also strategically focused on additional launches over the next 18 to 24 months.
And can you talk a little bit about the timeline for profitability?
Yes, that's obviously very important, and especially to our shareholders and then to our industry as well. And I think as we focus on our path toward profitability, I mentioned it a little bit earlier, an important part of our strategy actually is continuing our discussions with our customers, including whether it's defense contractors, international partners, space supply chain, commercial firms, whoever it might be, to educate them on the benefits of space-based data. We're very optimistic that our execution of customer contracts will accelerate with our launch dates that are defined, and this will result in that higher margin revenue growth, which moves us closer to profitability. But customer education is really vital. Being in an emerging industry, we're not necessarily competing over pricing, but really what we're looking at is we competing over educating the customers on the benefits of our system. So those non-traditional types of industries and customers, with a really good foundation in place, there's a little bit of a short supply of space-based data providers, and with the increasing demand for that data, we expect that our focus on the recurring customer base and our recurring subscription revenue, combined with the high margin nature of that data, will result in that faster path to profitability.
Now, the sky is the limit, right? That's not just a pun, that's real for you. But talk a little bit about some of the challenges. What are some of the challenges that you see in achieving some of this, these high things in the business?
Sure. I've kind of already touched on it a little bit, the launch schedules, your launch providers, although we're seeing more and more small satellite rocket launchers enter the industry, and that is a benefit to satellite operators. And it's a benefit because we have more access path to space, but also because it brings the cost down and makes it a little more competitive. And then, of course, supply chain sometimes can be a challenge. We've been able to mitigate that, and we've been working with supply chain for many, many years. But I think one of the biggest, and I just mentioned this, the biggest is the fact that the space economy is in its infancy, and the challenge we face is educating our customers on the benefits of space-based data. So organizations sometimes tend to be hesitant to rapidly implement new ideas, even though the benefits can be highly substantial. But so we are, addressing this issue by creating easier ways to understand, such case studies, white papers, things that we believe can help educate customers and bring in new leads and help the industry share more about what the benefits are. So just as the early internet expanded educational opportunities, it enabled faster communication, created entirely new business models that weren't even possible, before its arrival. I think we've now reached a similar tipping point or inflection point with satellite data.
Now, you did mention this, but just for our audience sake, this is a new terrain, so I don't think you can repeat it enough. But what are some specific industries that can benefit from space data so you can help educate us a little bit more?
Sure. And you said, I'm going to say it again, the sky's the limit. It really is, and everyone, obviously, military and government are currently some of the biggest consumers of space data and satellites, but corporations in the energy, agriculture, mining, technology, transportation industries, I think will likely be some of those first rapid movers in our industry and from the non-traditional kind of industries. I mentioned before, the use case when it comes to agriculture. Those remote sensing satellites like ours provide farmers with that detailed information on crop health and soil moisture, weather patterns. All of that information can be used to optimize the crop yields, reduce the use of water and fertilizer. These are all global concerns and useful. And by using this data, the farmers can make more informed decisions, which ultimately leads to increased productivity, reduced costs, and everyone kind of thrives. The commodities markets, again, can see the impact. And it doesn't only impact farming businesses, but it's downstream beneficiaries as well. So, a more efficient agriculture environment, really translates down to including, for grocers and restaurants. And you can just really see the economic multipliers that come out of something like this.
Absolutely. No place to go but up, and that's where we're headed. So, Carol, do you have any closing remarks for our audience today?
No, I just want to say thank you for everyone's time. And we're very much excited about it. Like I said, it's not if, it's when.
That makes a lot of sense. Thank you so much for your time and presentation, and we look forward to having you back with some updates.
Thank you so much, Anna.
All right, everyone, stay with us. We'll be right back with our next presenter.